Hello everyone, welcome to this number pattern question where we are given the first 5 terms and we are actually tasked for part 1 to write down the next 2 terms, T6 and T7, in the sequence. So for part 1, right? Then T6 will be equals to 1 plus 2 plus 3 plus 4 plus 5 all the way until 6. This will give me 21. T7, I just need to add all the way until 7. So part 1 is done. Now for part 2, they actually give us the end term of the sequence. And now our job is to make sure that the 7th term is indeed 28 when we apply the formula, which is the end term. Okay? So for part B, part 2, all we have to do is simply to apply the formula by substituting all the n as 7. And this indeed is equal to 28. Shown. Part 3. All we have to do is to use the formula to find T100. Okay, so part 3 is pretty straightforward. T100 is therefore substituting n as 100 to give us a value of 5050. Now, we are coming to part 4, okay? So for part 4, we are going to use the answer in part 3, which is this answer, to help us to find this sequence where we continue to add 5 to the previous term. 5 plus 10 plus 15 plus 20 plus da 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 da. So for this particular question, I'm going to write it here. I'm going to start with, of course, 5 plus 10 plus 15 plus 20 dot, 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 dot. And we continue to add 5 until we reach 500. So this is important because by knowing that we keep on adding 5 to the previous term, all the numbers here, if you notice, the first observation Mr. Tan here made is that all the numbers are multiples of 5. Meaning they can all divide by 5. 5 is a common factor. And I'm going to take out 5 as a common factor. I'm left with 1 plus 2 plus 3 dot, 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 plus 100. And comparing with the pattern. Previously, I saw that the number pattern is, if the first term is 1, is 1. If it is 2, 1 plus 2. If it is 3, 1 plus 2 plus 3. 4, 1 plus 2 plus 3 plus 4. 5, 1 plus 2 plus 3 plus 4 plus 5, all the way. So from here, you can then see something. This 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus all the way to 100 is actually our 100 term. And wait a minute. Oh, we've got our 100 term here. 5,050. No wonder they asked us to use the answer in part 3. We all have already gotten the answer from part 3, which is 5 times 5,050. And therefore, final answer, it will be 25,250. For part 5, hence, once we know this, find the sum of all the whole numbers from 1 to 500 which are not multiples of 5. Oh. Okay, so now we need to add up from 1 to 500. Okay, so for part 5, 1 plus 2 plus 3 plus 4 plus all the way to 500. Then I realized this looks similar, and this is actually, if I go back to this number sequence again, what we're actually trying to find here is T500. Okay, and this will be equals to half times 500, 500 plus 1. This will give me a value of 125,250. But this is not the final answer, okay? Because we are actually tasked to find the sum of all the numbers, whole numbers, from 1 to 500, which are not multiples of 5. This includes multiples of 5. Wait a minute. Multiples of 5? Oh, multiples of 5. Multiples of 5. Multiples of 5, I actually got the answer from part 4. No wonder they actually asked us to use the word hence, meaning we have to use the answer from part 4. So therefore, the final answer here will be that they are actually the required answer. The required sum will then be equals to 125,250. This is everything. I minus away the sum of all the numbers from 1 to 500 that are multiples of 5, which is this, to give me the final answer, 100,000. With that, we have come to the end of this question. So if you like this video, do give it a thumbs up. Thank you for watching and have a nice day.